Hello everyone, welcome to this lecture on bisection method. My name is Dr. Vikrant Yadav. I am an assistant professor in Department of Mathematics, School of CS and AI at SR University, Warangal. In this lecture, we are going to study an important numerical technique used to find the roots of equations, that is, the bisection method. Before moving ahead, let me briefly tell you why this method is important. In many real-world and mathematical problems, we often encounter equations that cannot be solved using direct algebraic methods. In such cases, we rely on numerical methods to obtain approximate solutions. The bisection method is one of the most basic and reliable techniques among them. In this lecture, we will cover concept of bisection method, its working principle, its step-by-step algorithm, its graphical understanding, the convergence idea, and some solved problems. Okay, one of the biggest advantages of this method is it is very simple to understand, it is easy to apply, and most importantly, it guarantees convergence under proper conditions. So I recommend you to stay till the end of this lecture as we will build a strong conceptual foundation that will help you solve numerical problems with confidence. Let us begin with the basic idea of bisection method. Alright, now let us understand what exactly is the bisection method. First, look at the definition. The bisection method is a numerical method used to find the root of a nonlinear equation of the form fx equal to 0. Okay, so our main goal is very clear. We want to find the value of x for which the function becomes 0. Okay, this equation and it's the value of x we need here for which this function f will become equal to 0. Now, what is the basic idea behind this method? This method is based on a very simple concept. Okay, we repeatedly divide an interval into two equal parts and then select the part in which the root lies. So instead of solving directly, we narrow down the interval step by step until we reach the root with desired accuracy. Now let us move to the key idea. There are three important points here. First is that we should start by choosing two initial guesses. Okay, then we are having just two values a and b. Okay, which will define the interval a comma b. Correct. The second point is we must ensure that the function's value at these 2 points, that is a and b, is the product should be equal to less than 0. Okay, this condition should be satisfied here. That is fa into fb should be less than 0. It means that one value, that is fa, and the other value fb, there will be a opposite sign. Okay. Now, if the condition is satisfied, then this method guarantees that the root will lie in the interval a to b. And this is the foundation of the entire bisection method. Okay, now let us understand the process. The steps are very simple. Okay, first we divide the interval into two equal halves. So basically, we find the midpoint of the interval. Okay, say the interval is a comma b. Here, the midpoint will be m equal to a plus b divided by 2. Okay, now we check the value of the function. We check the value of the function f of x at the point m. That is, we find f of m. Okay. Now we check which half contains the root. We do so by again and again checking the sign of the function. Okay. Now we select that half in which root lies and discard the other half. Simple. And we just keep on repeating these steps again and again until we reach the required accuracy. Okay. So if I summarize this in one line, bisection method is a systematic interval reduction technique. Okay, so one important thing that you should remember is that this method is guaranteed to converge, but the speed of convergence is relatively slow because we reduce the interval step by step. Okay, in the next part, we will understand the working of this method visually and mathematically, which will make the concept more clearer. Right, now let us understand the bisection method graphically. This part is very important because it gives you clear visual understanding of why this method works. Look at this graph carefully. On the vertical axis we have f of x, okay, and on the horizontal axis we have x. The curve you see here represents a function. Now try to observe this, that we have 2 points on x-axis, that is A is here and B is here. Okay, these 2 points define the interval A comma B. Now just try to focus on what is happening between these 2 points. You can see that the function crosses x-axis somewhere between A and B. Say this point, okay? This point we name it as alpha. What does this crossing mean? It simply means that at that point f of alpha is equal to 0. Okay, so this point alpha is actually the root of the equation. Root of the equation f of x equal to 0. Okay, now let us move to the observation given on the slide. If the function crosses x-axis between a and b, then we can confidently say that our root will lie between this interval a to b. But how do we identify such an interval mathematically? Okay, this is where the sign change condition comes into picture. Look at this condition, that is f of a into f of b less than 0. What does this mean? It means that f of a and f of b both are of opposite signs. One is positive, the other is negative. And when a continuous function changes sign over an interval, means becomes positive to negative, it must cross x-axis somewhere in between, just as you can see in this adjoining figure. This ensures that there is at least one root in the interval a to b. This is the foundation of bisection method. Without this condition, we cannot guarantee the existence of a root. So, if I summarize this visually, we start with the interval a to b, okay, and then the function values at these points have opposite signs. This is the second condition. Therefore, the graph must cross x-axis, and that crossing point is our root. Okay, I hope you are getting it. So let us continue to the next slide. Alright, now let us move to the most important part, of bisection method, the formula and algorithm. Okay, this is the part you will actually use while solving questions. Let us first understand the midpoint formula. We calculate the midpoint formula of the interval using this equation, that is xn equals to a plus b upon 2, where a and b are the endpoints of the interval. What does this mean? It is simply giving you the midpoint of the interval. So every time, instead of guessing randomly, we systematically choose the midpoint. Instead of random guesses, we are getting a regular, that is a middle point of the interval, that is a plus b by 2. Now, why midpoint? Because the bisection method works on dividing the intervals into two equal parts. So this formula is very used in every iteration. Okay. Now let us understand the error bound. Error is less than or equal to b minus a over 2 raised power n, where n is the number of iterations. So you can see that how accurate our answer is after n iterations. Okay, so error decreases exponentially with iterations. So here you can again think of it that as n increases, the denominator decreases, and so denominator basically increases, and the whole this quantity on the right hand side b minus a over 2 raised power n decreases. So the error becomes smaller and smaller. That means the error is decreasing exponentially. So even though the method is simple, it becomes more accurate with each step. Okay. Now let us move to the algorithm steps. This is what you should remember for exams. In step 1, you just start with by choosing the interval a comma b. Then you check the condition, that is f of a into f of b less than 0. F of a and f of b, as usual, are the values of the function f of x equal to 0. F of x at the points a and b. And the product of these two values at f a and b should be less than 0. If this condition is not satisfied, the method cannot be applied. Okay, so at the third step, you just compute the midpoint using the formula x equal to a plus b by 2. In step 4, you evaluate this function, the value of the function at the point x, which is equal to the midpoint. Now check the sign of f of a into f of x. It should be less than 0. Okay, if f of a dot f of x is less than 0, then b will replace b with x. If the second condition can be that f of x dot f of b can be less than 0, in that case we'll replace a with x. Okay, for x with a, you can replace the value of the new a will be new a will be equal to x. Okay, now we shall repeat this process from steps 1 to 6, okay, again and again until we reach the desired accuracy or convergence. So in simple words, at every step we reduce interval size and move closer to the root. This method is very systematic and error controlled, which makes it extremely reliable. Okay, so let us move to the next slide. Alright, Now let us move to a very important part of bisection method. That is when to stop the process and what are its properties. First, let us understand the stopping criteria. Okay, when we apply bisection method, we cannot continue infinitely. So we need some conditions to decide when to stop. Okay, there are commonly three conditions which we use as stopping conditions. First condition is f of x, mod of f of x is very small, or you can say that the value of the function is very small. In that case, we stop. This means we are very close to the root. Second condition is that when an interval length, okay, interval length becomes very small, that is the difference between a and b is very small. This indicates that we have narrowed down the region enough. Okay, then third condition is when we achieve the required decimal accuracy. For example, if the question asks for the accuracy up to 3 decimal places, so we stop once that level is reached. So depending upon the problem, we can use any of these criteria. Now let us move to convergence. This is one of the strongest features of bisection method. Okay, the method will always converge provided two conditions are satisfied. The first condition is that f should be continuous on the interval a to b. And the second condition says that the sign change condition must hold. If these two conditions are satisfied, then the method is guaranteed to reach a root. Sign change condition here means f of a dot f of b should be less than 0. Okay, so that is why bisection method is considered one of the most reliable methods. Now let us discuss the advantages. It is very simple and easy to implement, that even beginners can understand and apply it easily. Okay, if it provides guaranteed convergence, this is a very big advantage compared to many other methods. And if it does not require derivatives, so even if differentiation is difficult, we can still apply the method. Okay, these three advantages are there mainly. Now let us look at some of the disadvantages of this method. This method, okay, the convergence is very slow. In this method, we are able to observe that the convergence is very slow because it is specifically linear convergence. So it takes more iterations to compared to faster methods. Okay. Also, it requires a valid initial interval. That means we must find and such that the sign condition holds. Again, it cannot find multiple roots directly. Okay, it cannot find the multiple roots directly because it only works within one interval at a time. So overall, this method is very reliable, very simple, but comparatively slow. So to summarize, I can say that the bisection method is a guaranteed but slow converging method with clear stopping rules. Okay, so with this, let us continue to the next slide. Alright, now let us start with a practical problem based on bisection method. This is important because this is the type of question you will see in the exams. Now let us carefully read the problem statement. A mechanical engineer is studying a vibrating system, and the displacement is modeled by the equation f of x equal to x cubed minus x minus 1 equal to 0. Now we are asked to find the real root correct up to 3 decimal places, okay, using the bisection method. So what is our objective here? We need to find the root or value of x such that the answer or the value of x must be accurate up to 3 decimal places. Now before applying the bisection method, the first and foremost step is to find a valid interval. Okay, we need to choose two values, say 1 and 2. Okay, and such that f of 1 dot f of 2 should be less than 0. Okay, then this condition f of 1 dot f of 2 less than 0 will ensure that the root will lie between the interval, the root alpha or x, whatever you call it, will lie between a and b. Okay, where a equal to 1 and b equal to 2. Let us check at a equal to 1. Okay, so we are getting the value at the function f of 1 at the value is minus 1. So at x equal to 2 or b equal to 2, whatever you call it, f of 2 will be equal to 5. From this equation, f of x equal to x cube minus x minus 1, right? Now you check the condition, that the condition gives you minus 1 into 5, that is equal to minus 5, which is less than 0. We carefully can observe that it is negative. Okay, so this means the sign change condition is satisfied. Therefore, we can conclude that the root lies in the interval 1 to 2. This condition is satisfied. Okay, so the root will lie between 1 to 2 interval. This is very important step. If you don't find a valid interval correctly, the method will not work. So always remember, first find an interval where the function changes sign. Okay, then apply the bisection method. Now that we have identified the interval, we are ready to move to the next step. Okay, finding the midpoint and starting iterations. So let us continue to the next slide. Alright, now we begin with the iteration process of bisection method. We already found that the root lies in the interval 1 to 2. Okay, so here the interval a comma b is already, that is 1 comma 2 interval. So root is lying between this interval. Okay, now we will apply the method step by step and observe how the interval keeps shrinking. Look at this table carefully. We have columns for iteration number, that is 1, 2, 3, 4. These are iterations. Then it is the value of a. Okay, value of a, and this is value of b. Then this xn is the middle point or the midpoint of the interval a comma b, which is given by a plus b by 2. Then we have the function's value f of xn, that is at the midpoint of the interval a comma b. Okay, so first of all we'll apply this, the value of a b. Okay, so we are going to find out the value of the function at the point, first middle point, this. So it will be 0.875, which is positive. So we can guess that since the interval is from a to b, Middle point is, say it is xn. Here the product of this, that is f of a and f of xn. If this product f of xn, a and f of xn is less than 0, then root will lie between a and x. Okay, so new interval will be a to x. And if the product of f of xn and f of b is less than 0, in that case root will lie between x and b. Okay, but here the case is the product of f of xn, sorry, f of a and f of xn, that is f of 1.5 is negative because f of a is negative 1 minus 1. Okay, f of a is minus 1, so the product will be negative. That means the new interval will be 1 to 1.5. Okay, now in the next iteration the interval is 1 to 1.5, that is the new value of b is 1.5 here. This value will go here, right? After that the next midpoint is 1 plus 1.5, this plus this divided by 2, that will be 1.25. And the answer of the function, or the value of the function at this point 1.25 will be this value. Okay, this value, that is minus 0.296875. So definitely the value of the function at the point 1.5 is also positive, and at 1.25 is negative. That means the new interval is 1.25 to 1.5. You just keep on checking the values of the function at the points a and b. Okay, that's it. So similarly, in the next iteration, that is iteration number 3, the new interval will be, this value will be shifted to here in place of a. Okay, and the new interval becomes 1.25 to 1.5. Now again we'll calculate the midpoint of this, that will be 1.375. After that the value of the function at this point is 0.224609, which is again positive. So new interval will be definitely equal to 1.25 to 1.3750. Okay, so in fourth iteration the interval is 1.25 to 1.375. Again we'll keep on repeating this process. Okay, so basically after 4 iterations you are able to see that the root is bracketed, or root lies in this interval, which interval 1.3125 to 1.3750. Okay, also just see that the interval length or interval width is reduced from 1 to 0.0625, which shows that we are getting closer to the root. Okay, so I have calculated 4 more iterations for the same problem, in which iteration number 5, 6, 7, and 8. So here you observe that we are progressively getting near to the root. Okay, in the previous slide we had root in some particular interval. Here the root is we are progressively narrowed to this interval, that is 1.32422, and then it is 1.32813. Okay, you can observe here that the first three, 1.32 and 1.32, are repeated. Okay, so we are getting closer to the real root, actual root where it lies, right? So after 12 iterations, you will be able to see that the root actually lies between this interval, that is 1.373247 and 1.32495. So this value is getting repeated till the third decimal place, 324, right? So the actual root is approximately equal to 1.325 that we will consider. Okay, this is correct up to 3 decimal places, right? This is how we calculate the approximate root using bisection method. Okay, I hope you enjoyed it.
If you found this video helpful, don't forget to like, share, and subscribe to the channel. Thank you.